It's important for you to remember that all quadratics have the same standard form, and that standard form is ax squared plus bx plus c equals 0. So notice that if I draw my line down the equation, that everything is on one side, that all of the terms are on one side, and the other side of the equation equals 0. It's also important to note that your exponents go in order from biggest to smallest. So our first exponent is a 2. There's an x squared, then there's an x to the first, and then this has the constant here has no x's. And they do have to be in this order, that it has to be x squared, then x, and then the constant term. So I have two problems that I need to get into standard form. The first one says 3x squared equals 2x minus 7. So I'm going to draw my line through my equal sign. So I need to move either the 3x squared to the right or the 2x minus 7 to the left. Well, if I move the 2x and the minus 7, that's moving two things versus moving just the 3x squared, which is moving 1. So that's what I'm going to do. I'm going to pick up the 3x squared. I'm going to move it to the right. And it was positive on the left side. So on the right side, it's going to be negative 3x squared. Now, it's also important to note that when you look at standard form, that the exponents are written in order from biggest to smallest. So the first thing I need to have is 0 equals, the very first term I'm going to have on the right side is my negative 3x squared, because that has the exponent with it. Then I'm going to have my 2x, which is positive. So I'm going to put plus 2x. And then lastly, I'm going to have my minus 7. And this is what standard form looks like. So we have another example. Negative 4x equals 6x squared plus 5. So if I draw my line, I need to get everything to one side. Again, it's going to be easier for me to move the negative 4x over. So if I pick up the negative 4x and I move it over to the right side, it's going to become a positive 4x. And then this is gone. So on the left side, I have 0 equals. And if I start writing things in order, the first thing I'm going to have is my 6x squared. My next thing is going to be my plus 4x. And the last part is going to be the plus 5. So we again talked about root solution zeros and x-intercepts, which recall root solution zeros, x-intercepts, all four of these words mean the same thing. They're all talking about where a graph crosses the x-axis. So here and here. This particular graph has two. We're going to call them solutions this time. You could also have a graph that has no solutions, like this one, because this graph that's yellow never touches the x-axis. Or you can have a graph with one solution, and one solution is going to touch the x-axis and go right back up. So this particular graph has one solution. Those are our three choices. So I have some examples to look at. Number 3, I want to know what are the solutions. Well, my solutions are here and here. And noticing that this is 0 and this is 2, that tells me that in here in the middle this is 1. And then this is going to be 3, 4, here's 5, and there's 6. So my solutions in this case are 1 and 5 because that's where it crosses the x-axis. If I look at number 4, well, here's my x-axis, and I'm going to highlight that in green actually. Here's my x-axis, and then I'm going to highlight my graph in pink, and here is my graph. And notice they never intersect, so that tells us that this graph has no solutions. This graph has no solutions, which also means that it has no zeros. It has no x-intercepts. And it has no roots. So this graph has no roots, no zeros, no x-intercepts, no solutions because it never touches the x-axis. Our next graph, it touches the x-axis here, and that's at 3. So this has one solution, which is just 3. Lastly, it's important to remember what a minimum and a maximum are. So remember, if your graph opens up, like this parabola on the left, if it opens up, it has a minimum. This vertex is a minimum because it's the lowest point on the graph. And if the graph opens down, then the parabola has a maximum. And these points, recall, are the same thing as our vertex. They're both vertices. They just have different names because one's at the top and one's at the bottom.